Saxon's Calculus Lesson 61 is about integration by guessing. And as the title suggests, you're going to be making a guess as to what your u should be and then working the integration backwards. Now, I started this a minute ago and for some reason just could not wrap my head around working backwards. And so I had some issues and I just scrapped that one and started over. So let's begin with the discussion here of Example 1. So it asks us to find the integration of 20x with 2x squared plus 4 to the fourth power dx. So I'm going to make an assumption that the messy stuff here is the u. So I've written u is 2x squared plus 4. And then I've derived that to get 4x dx. Now, this is where I was having trouble. In this original, if this is where I'm landing, I'm assuming that I'm adding 1 to the exponent, and this is u to the fifth. That being the case, I'm going to make that 5u to the fourth when I derive it. And then if I substitute in for the u, I've got 5 with the u, 2x squared plus 4 to the fourth power. And that is multiplying, of course, with the du, which was 4x dx. Now, if I simplify that, I get 5 times 4 is 20x with all of this stuff to the fourth power dx. Is that what the original was? Yes. Okay, so you're kind of working the problem with a guess and then testing it to make sure that it goes back to the original that you were given. Now let's write the answer in its u to the fifth format. And so that would be 2x squared plus 4 to the fifth power. But because it is integration, it always has the plus c with it. Now let's work on example 2. Integrate 7 sine to the sixth t multiplying with cosine of t dt. And I like to throw a parenthesis around those just so it doesn't kind of get lost in the problem for me. So I'm going to assume that my u should be the part that is messier, so that's the one with the 6. So my u is going to be sine of t. That makes my du cosine of t dt, and then that means that I have here u to the 7th, so then that should work to, running out of space, u to the 6th power. Yes, and then my 7 would come over here. My u would be sine of t to the 6th power, same thing written that way. And then the du, which is cosine of t dt. Now, how close does that compare? Cosine t dt, got it. Sine to the 6th, same thing, and the 7. So yes, my guess was correct, and I've proven that I get to the original. So now let's put it back into our u to the 7th. So that would be sine to the 7th t plus the c, because we always have that in our integration. Example 3, integrate 3x squared dx over 2 root of x cubed plus 4. So we're going to make a guess that our messy stuff, I'm debating. Do I want to change that over? You know, I think I do want to change this root over before I make my guess. So this is 3x squared. My 2 is still down here. And because this was a negative, I'm going to write all of this stuff up top as x cubed plus 4. And down here, oh, wait a second. No, this would be the positive if I leave it down here. Hang on a second. X cubed plus 4 to the 1/2 is that exponent. If I move it up there, I make it negative. You know, I think I do want to make it negative because if it's all in one line, it's easier. So let's make it negative 1/2 up here. So now you see where I got that from. So I've got a constant 3/2 x squared. So yeah, this is basically then one straight line. That is much better. Now I'm going to assign my u to be the x cubed plus 4, the the du to give us 3x squared dx. And now, and I'm already seeing that the du is the 3x squared from here. I don't have the 2 for sure, but this is my u statement, so I believe it should be u to the, add 1/2. Okay, so then if I work that out, it becomes 1/2 u to the negative 1/2. I think we're getting there. So now if I plug in, we have our 1/2 with our u, which was x cubed plus 4 to the negative 1/2, multiplying with our 3x squared, which puts it on the top. So 3/2 x squared, yes. All right, so now we just need our answer, our u, which was our x cubed plus 4 to the 1/2 plus c. X cubed plus 4 to the 1/2 plus c. Yes, okay. Now example 4. Integrate 8x multiplying with e to the 4x squared dx. All right, so everything is in a line, so I don't need to worry about moving anything around. We're going to assume that our guess is u equals the e to the 4x squared, making du, the e does not change, so e to the 4x squared. However, I do have to derive the exponent part to derive every piece, so that makes it 8x dx. And then our original u, see, there's my 8x, and so, and that's the original. I don't feel like I need to make a change to that. So my u is already here. I don't need, so this one is actually a little touch easier. So because I already have the 8x multiplying with this, my original then is e to the 4x squared plus the c. Now, example 5, integrate 12x squared plus 2 over 4x cubed plus 2x dx. Can I put everything together on the same line? I can factor a 2 out of everything, but I'm not sure I want to do that. And the other thing I'm seeing is that this looks like a 1 over something that's been derived. So I'm guessing that it's a natural log of u that I'm dealing with here. So I'm going to set the u as the bottom stuff. U equals 4x cubed plus 2x. Du equals 12x squared plus 2. There's the top, dx. Beautiful. Okay, so then if I natural log the u, when I derive that, I would get the 1 over u multiplying with this stuff. That would put this stuff in the top with the 4x cubed plus 2x in the bottom. Perfect. So my answer then is natural log of the u, which is 4x cubed plus 2x. And I would encase that in an absolute value because I don't know at this point with the integration whether it's positive or negative, and then the plus c. Example 6. Integrate -4 e to the 4 cosine x multiplying with sine x dx. So I'm going to guess that my u is the e to the x stuff. So e to the 4 cosine of x. And that looks like a 4, not a u. So du would be e to the 4 cosine of x. And then I need to derive the exponent. So that's going to go to 4 negative sine of x dx. Now, how close are we? Negative 4 e to the 4 cosine x with the sine. That's it exactly. So now I just need to write out that it is e to the 4 cosine of x plus c. And the last example, find the integration of 2 cosine of x sine of x dx. Now, this one doesn't have a messy piece. It's a cosine and a sine multiplying with a 2. So I have to make a guess whether I want to do sine or cosine. Now, the book chose to do sine. So let's try that. If I make the u sine of x, the derivative is cosine of x dx. The other reason I like choosing the sine is that it doesn't throw a negative in here. I don't see a negative, so I feel like that's my best choice. And then this gives me the cosine, this gives me the sine, but I don't have my 2. So is it possible that my original was, oh, actually, I want to say u squared, because then if I derive that, it would give me 2u, and that inserts the 2 into the problem. So now, if we test that, that's 2 multiplying with sine x, and then the du, the cosine of dx, that gives me the list. So yes, that was a good call. 2, then this was sine squared x plus c. Oh, the 2 is not part of my original because it was just u squared gave me the 2u. So u was sine squared plus c. Yes, that makes a little more sense. Now, what did they do here? Oh, okay, they said I could have done the cosine one and inserted it then as a negative and gotten negative cosine squared plus c. But again, I've already said that I prefer to avoid that negative.